Alright, welcome to this last video where we're looking at the different concepts which are now left. It's really only a small part related to the unit on lens. So something I think it's important for students to know, even though it's not part of the syllabus, is how images are formed in the diverging lens. So a sample ray diagram is given. Rule number one, exactly the same, which is that the ray which goes through O remains totally undeviated. So rule 2, it no longer can be this, that this ray goes through this point, because it's no longer going to come together. Instead, we know it's going to spread out. So the way it spreads out is such that if I take this apart, the light ray, when extended back, it appears to pass through the focal point on the same side. So for example, if I were to take this back, it appears to pass through this F. All right. So this is how the rays are. Again, how does the image formation look like in this case? Obviously, it's not going to be a real image because these two rays are never going to intersect on this side of the lens. So if I take these rays back, they intersect here again because these are dotted rays, even though this one might not look like it, but in reality, it's also a dotted ray because I'm taking this back behind the lens to see where they intersect. This is where the image is formed. Alright, so that's how image formation works in the diverging lens. Again, if I were to just describe the properties of this image formed, so first of all, it's virtual, right? So the rays just appear to be coming from the image. And again, if you think about the observer would be placed here to see the formation of the image. It's also on the same side as the object. It was also the case with case 6 that we did in the last video, that both of these go hand in hand. A virtual image is always formed on the same side as the object as well, as far as lenses are concerned. All right. Third, it's an upright image. And with regards to magnification, this is a diminished image because the image is smaller than the object. So I would say that in terms of magnification values, this would be less than 1. So this is pretty basic stuff. And you don't even need to know this all that much. What is more important, what is something that is assessed a lot, is the idea of defects of vision. So how the retina undergoes changes, and whatever those changes are, how we remedy those by choices of appropriate lenses. So if we have a healthy eye which is free of defects, in that case the rays coming in from whatever object we are looking at, they converge at the retina, and this gives us a sharp and focused image. Alright, then the brain processes it and shows it to us. When we talk about the defects of vision that happen, one of these is called short-sightedness. In Urdu or in Hindi, this is called dur ki nazar kharab hona, and that basically means that you cannot see objects further away, but objects nearby are fine. So objects nearby are visible, but the ones further away are blurry. Now, how would you remember what short-sightedness is? Because this is also a task. So short-sightedness basically means that the image forms a short distance after the lens. All right, and the image, as you know now, is formed where the rays cross over. So these rays that we have, they cross over way too early for the formation of the sharp image. So they were supposed to cross over here, they cross over here. So the image in this case is obviously not clear as it's formed before the retina. Now again, the stuff that follows is very, very basic. You know that for the sharp focused image, for the sharp focused image, the rays must meet at the retina. So what type of lens would you use to make it meet here? You basically need to make the rays spread out a bit more, right? You want them to spread out a bit more, for which you will be using a diverging lens. All right, so in this case, what will happen is that such a ray is going to spread out the rays beforehand before they enter the lens of the eye. All right, and then because it was weak at converging, these are already spread out, so they would come to meet at the retina like this. Very, very straightforward. Similarly, for long-sightedness, which means करीब की नज़र खराब होना, so this basically means that you cannot see objects nearby, but objects further away are fine. So objects nearby are blurry, and objects further away are visible. With regards to how do you remember this, it's again the same way as you remembered short-sightedness. For long-sightedness, the image forms a long distance after the lens. So again, as with short-sightedness, the image was forming before the retina. In this, the image is formed after the retina. So it's basically the reverse of short-sightedness. So the rays must have met at the retina. In this, they've not still met when they pass through the retina. So that looks like this, probably like this. So they've still not met, even though they were supposed to meet at the retina. All right, again, this is also very easy. Because you want to make them meet at the retina, you need a lens which will make them bend more. That will make the light rays come together. So for this case, you need a converging lens. And how would the converging lens look is basically these would already be coming closer together. Let me zoom in here for a better drawing. Like this, and then the light rays will bring them together. In such a way, like this. All right. Again, my drawing is probably not the best right now, but this is the idea. All right, so bending occurs here as well as here to make the rays again meet at the retina. So that's the idea here. So that's the end of lenses. Now, once you've watched the videos properly, feel confident to go ahead and try out past paper questions. That's the only way that you'll know that you actually know the concepts. So like, share, and subscribe. Share this playlist with whoever you think could benefit from this, and drop a like, a comment if you want to see anything else according to your preparation needs. Thanks for your time, and until next time. Bye bye.